Hi everyone, and welcome to lesson 1.6, which is the standard normal distribution. If you haven't watched the 1.5 video, you'll want to go back and watch that and look over how to find z-scores, and also you'll want to be knowledgeable about the empirical rule. So today we're going to focus on the normal distribution when we can't use the empirical rule. Okay, but let's really quickly review using this problem here. So you can feel free to pause the video and try this problem on your own, and then unpause it when you're ready to go over it. In the year 2000, SAT math scores could be described by a normal distribution having a mean of 514 and a standard deviation of 113. The SAT math scores are plotted on the horizontal axis, and they are plotted one standard deviation apart. So below the graph, we want to write the z-score below each SAT score. So I want us first to look at this distribution, and in the center right here, we have our mean. And then we're going to look at each of the numbers to the right and to the left of the mean and figure out where they got those. So it tells us that we have a standard deviation of 113. So all we're going to do is add 113 to 514, and that gives us 627. Okay, this is one standard deviation above the mean. And then 627 plus 113 gives us 740. And 740 plus 113 gives us 853. So here, this 514 refers to a z-score of 0, which just means it's in the center. 627 is one standard deviation above the mean, so that means z equals 1, 2, and then 3. And then if we go backwards to get 401, we just subtracted 113 from 514. So this would give us -1, -2, and -3. And remember, these z-scores just represent 1, 2, and 3 standard deviations below average. That's what the negative implies. So when we looked in 1.5 at the empirical rule, remember that we were told that 68% of the distribution, 68% of the values fell within one standard deviation of the mean. 95% fell within 2 standard deviations of the mean. And then 99.7% fell within 3 standard deviations of the mean. So question B says 68% of the scores will fall into what interval centered at the mean? And if we look here at our graph, 68% will fall between 401 and 627. So that means that of the people who took that SAT math test in the year 2000, that approximately 68% of the scores fell between a score of 401 and a score of 627. Okay, let's look at another example. So let's say this time we want to compute what percentage of scores fell between 500 and 700. The problem is we can't use the empirical rule now to figure this out, because 500 is somewhere over here and 700 somewhere over here. So we can't use the 68, 95, 99.7. So we have to rely on technology to give us the percentage. In the past, we also used statistical tables, and this was like prior to having technology that would make it easier for us to find those percentages. So since 500 and 700 are not exactly 1, 2, or 3 standard deviations from the mean, the first thing we need to do is figure out their z-scores. So to find a z-score, remember the formula, in case you don't remember, is just the value minus the mean divided by the standard deviation. So here the value is 500, the mean of that distribution is 514, and the standard deviation is 113. So for someone that scored a 500, the z-score is negative 1.2, which just means that anyone that scored a 500 scored 0.12 standard deviations below the average. And for someone that scored a 700, they have a z-score of 1.65, which just means that they scored 1.65 standard deviations above the mean. And I know it's above because it's a positive. So how do I figure out what values fall between those two? Okay, so what I'm looking for basically is something like this. So think of the 500 is right here where this red flag is, and the 700 is right here where this red flag is. And I need to find the probability or percentage of the area between those two flags. So the way I'm going to do that is I'm going to use the calculator. So we're going to pull up our graphing calculator. Okay, and again, I'm going to be using the TI-84 Plus. And what I need to do is go to second and then vars, which is to the left of the clear button and to the right of that magnifying glass. And we're going to pick normal CDF, number 2, always and forever. Okay, you're never going to pick normal PDF. Normal CDF stands for normal cumulative density function. So that's the one we're going to pick. So you can either hit the arrow down to number 2, or you can just type the number 2. And then you're going to hit enter. And what we need to do is enter the lower bound and the upper bound. So what we mean by that is the lower bound is the left z-score, and the upper bound would be the right z-score. So if we go back to our notes, we can see that the lower would be the negative 0.12 and the upper is 1.65. So again, if you go to the graph where the 500 was and you need to visualize it, here for 500 it had a z-score of negative 0.12, and for 700 it had a z-score of 1.65. So this is considered the lower. Think of L for lower, L for left. And then this is the upper or the right z-score. So we're going to enter the lower, negative 0.12, and then the upper, 1.65. So negative, make sure you use the negative button to the left of enter. So negative 0.12. And then we're going to use the comma. The comma is right above the number 7. And then I'm going to type 1.65 for the upper bound or the right z-score, and then a comma. And then it's saying mu and sigma. So we want to enter 0 for mu because our mean is 0 when it's labeled using z-scores. And then the standard deviation is going to be 1 because each of those values is 1 z-score away from each other. And then just hit enter. And the answer is 0.4983. So that is giving us the percentage of scores that fell between 500 and 700. So as you can see here, the problem is worked out for us, and that is the value that we get. So there's a couple ways you can write this or interpret it, is that the probability is 0.4983 that a randomly selected SAT math score will fall between 500 and 700, or you can also say 49.83% of the SAT math scores were between 500 and 700. Okay, those two statements are equivalent. So when we are doing these problems, we want to make sure that we always make a sketch, so draw a picture of your normal model and label everything. Then we want to calculate the z-scores, Okay, and also place those on the table, on the graph, as I did. And then you want to use normal CDF on your calculator to get the area. So remember, the way we do that is we hit second vars and then number 2. And then we want to state the conclusion in the context of the question. Okay, so what's important in statistics is not always just calculating the values, but also being able to interpret it so that anyone can understand it. Especially, your target audience might be people that never had statistics before. So you want to make sure it's understandable to them. Okay, so here's a problem for you to try on your own. So you can pause the video, and then when you're ready, you can unpause it and we'll work it out together. What is the probability that a randomly selected SAT score will be between 600 and 700? We're still going to use that mean of 514 and standard deviation of 113. So let's create a picture. So here's my normal model. And my mean is going to go in the middle. So we know that's 514. Okay, and we can just copy the z-scores that we had written up top. So since the standard deviation is 113, we're just going to add 113 to each of those values. Okay, so if I do that, I'm going to get the following. Okay, and this time I'm looking for the probability that a randomly selected SAT score will be between 600 and 700. Okay, so let me shrink this a little bit so I can write some more things. Okay, so 600 is gonna go like right about here maybe. And then 700 we said was like right about here. And we're looking for between, so we're gonna shade in between them. Okay, so I can't use the empirical rule because, as you can see, we're not exactly one standard deviation or 2 or 3 standard deviations away. So I need to find my z-scores first. So first we're going to find the z-score for the score of 600. So for 600, it's going to be the value minus the mean divided by the standard deviation. And when you do that, you get 0.76. So that tells me that someone that scored a 600 on their SAT was scored 0.76 standard deviations above average. And then we already know for the 700 that was calculated before that the z-score was 1.65. Okay, so that's our first step in our calculations. Our first step is always to sketch the graph, but our first step in calculations was to find the z-scores. So for the 600, we know that the z-score was 0.76. So I'm going to put that on the graph here. I'm just going to write it above the flags since I don't have much room below. And then we know that the z-score for the 700 was 1.65. Okay. So step number 2 now is to calculate using normal CDF. Okay, so my lower bound is going to be the 0.76. My upper bound is 1.65. And then the mean is 0 and the standard deviation is 1. So remember, we know that because any value at the center, right, is the mean. And a mean always has a z-score of 0. And then we have 1, 2, and 3 standard deviations, -1, -2, and -3. So you're always going to leave the 0 And the 1, it's the z-scores that are going to need to change depending on the problem. So let's type that in and see what we get. Okay, so we're going to do normal CDF. So again, that's second vars, and then number 2. And it was 0.76 for my lower. My upper was 1.65. And the mean is 0, standard deviation is 1. And then hit enter. And you get 0.1742. So we're going to round to 4 decimal places. Okay, so I want to show you a little notation here. Really what we found was that the probability that someone's score was between a z-score of 0.76 and 1.65 is equal to 0.1742. Okay, so how would I write that in context? Well, there's a couple ways you could say it. I'm just going to say that the probability that a randomly selected person scores between a 600 and a 700 is approximately 17.42%. Okay, you could also say that approximately 17.42% of scores will fall between a 600 and a 700. Okay, here's another example. So we're not always going to be interested in finding probability or percentages between two values. Maybe we want to find the probability that a randomly selected SAT score will be higher than a specific value or lower than a specific value. So here we have our same problem, but this time we have our red flag right at 700. And this time I want to know what percentage of scores will be greater than that. So now there's no endpoint. There's no right bound. And I'm just looking for any value greater than 700. So if I'm looking at my sketch now, since I don't really have an upper bound or a right z value, I need to think about how I'm going to write that in my calculator command. So we know that our z-score for 700 is 1.65. Okay, we've been using that same value. So let's add that to our graph. So z equals 1.65. But remember, one of the properties of the normal distribution is that it goes on forever to positive infinity. So how do I show that on the calculator? I can't put positive infinity, okay? So what I would need to do is same steps, second vars, normal CDF, and I'm gonna choose 1.65 for my lower bound, right? Because that's the left side of the flag. Now there is no upper bound, right? It's infinity. So what do I put? So if you just pick a number like 100, okay, you could pick 1,000. It doesn't really matter. It doesn't make a difference once you get beyond that point. Remember, these are z-scores. So think about what a z-score of 100 would be. On the graph, you wouldn't even see it. So you could put in 100, 1,000, 1,000,000, it wouldn't matter. 100's a safe number to use. Okay, and then remember, we're going to leave 0 for the mean and 1 for the standard deviation, and then just hit enter. So the value that we're getting is 0.0495. Which should be here already. Yep. So what does that actually mean? It means that the probability is 0.0495 that a randomly selected SAT score will be higher than 700, or the percentage of scores higher than 700 is approximately 4.95%. Okay, feel free to pause the video and try this problem on your own. What is the probability that a randomly selected person, randomly selected SAT score will be lower than 500? We're still going to use the same statistics as before. The mean is 514 and the standard deviation is 113. And I want to clarify too, when they say the mean, it's really mu because it's the population mean. And when they say the standard deviation, it's sigma, okay, not S, because we're dealing with the population, like everyone who took that SAT. Okay, so here's my picture. We have our normal model, and we know that the 514 would go in the middle. And then I would have following numbers. Okay, and then the last ones were 853 and 175. Okay, so this time I'm looking for what percentage of scores will be lower than 500. All right, so again, 500 is not on our graph. So we can't use the empirical rule. So the first thing I need to do is I need to find the z-score for 500. And I believe that was found earlier, but it's okay to practice. You have 500 minus 514 divided by 113. So if I was to calculate that out, let's see, we would get negative 0.12. Okay, so that just means that if someone scored a 500 on their SAT, that they scored 0.12 standard deviations below average. Okay, step 2 of our calculations is to do normal CDF. Now remember, here our z-score is negative 0.12 and we're looking for the probability someone scored less than that or lower. So just like the normal distribution goes on forever towards positive infinity, it goes on forever to the left towards negative infinity. So how do I show that? So now my left bound is going to be negative infinity, or just use negative 100. And my right bound would now be the flag, which is negative 0.12. And then my upper bound, or my mean, is 0, my standard deviation is 1, and let's see what it gives us. So we have second vars, number 2, and it's negative 100, negative 0.12, 0, 1. And enter, and we get 0.4522. So what does that mean? It means that the probability that a randomly selected person scored less than a 500 on the SAT is 0.4522. Okay, and we should also say is approximately. Okay, and again, you can also state that as, the percentage of scores that were less than 500 on the SAT was approximately 4.522%. 45.22%. Okay. let's say now we are given the percentage and we want to find the math score that has, let's say, 25% of the scores below it. In other words, what's the cutoff? So if I was to look at this last problem, let's say I told you that the percent of students that scored less than a certain value was 0.4522. So what would be the cutoff? Like what is the cutoff for that SAT score? So we have to kind of work backwards. And luckily the calculator gives us a command to do that, okay? So if I am told, okay, the area here is 25%, and remember the area, the probability, the proportion, they're all the same thing. What is this actual value? So what I need to do is I need to use the inverse norm button, and it's in the same area as normal CDF. So you hit second vars, and this time I click number 3, inverse normal. Okay, and I'm gonna type in my percentage. So I'm looking for the SAT math score that has 25% of the scores below it. So I'm gonna type in 0.25 and then just hit enter. And it gives me negative 0.6745. So that represents the z-score. That's not the actual cutoff score. So I can use that though to find the cutoff score. So remember that the z-score formula is x minus mu over sigma, or value minus mu over sigma. Remember, I'm looking for x, or the value. So I'm trying to find what is that value right there, what number will go there. So if I plug everything into that formula, I have negative 0.67 equals x minus 514 over 113. Okay, and then I have to use some algebra to solve for x. So I'm going to multiply both sides by 113, and then the 113s will cancel out. And I'm left with x minus 514 equals negative 75.71. Then I want to add the 514 to the other side. So then I would be left with negative 75.71 plus 514, which gives me 438.29. So that cutoff score right here would be about a 438. So anyone that scored a 438 or less was in the lower 25 percentile, or the lower 25% of scores. So 25% of the math scores are below a score of 438. Okay, so I'm going to leave this last problem for you all to try, and it's a really good practice, culmination of everything we've done, okay? So try it on your own, and if you have any questions, feel free to ask me. Have a great day, everyone. Mean. Okay, so you're taking into account all these cars whose speed was taken. So that's your population. And then we found the standard deviation as well. It was given to us in this problem. This is our population standard deviation of 5 miles per hour. Okay, so we know that the mean goes in the middle because it's the average. So 35 is going to go in the middle. And since my standard deviation is 5, I'm going to add 5 to 35, and I would get 40. And that represents one standard deviation above the mean. Okay, 35 minus 5 is 30. That would be one standard deviation below, and so on. Okay, I'm going to go back to the mean. 35 plus 5 gives us 40. 40 plus 5 is 45. 45 plus 5 is 50. So this is 2 standard deviations, 3 standard deviations. And if I go backwards, I'm just going to subtract 5 each time. So we know that this 25 miles per hour is 2 standard deviations below, and 20 miles per hour is 3 standard deviations below. So there's my normal distribution set up according to this problem. And by looking at it, I know that my mean is 35, And these are your z-scores. If you're a car that's traveling 40 miles per hour, right, you are 1 standard deviation above the average speed. Okay, so these represent the z-scores. Okay, so that would just mean z equals 1, and this means z equals -1. So if you're a car and you're traveling 30 miles per hour, you're actually 1 standard deviation below the average speed of the cars on that road. So then answering these questions, what is the probability that a randomly selected car on this road is traveling below 25 miles per hour? So think of this right here is our 25, and I'm going to put a little flag right here. We want the probability that any car randomly selected, right? So any car would have an equal chance of being chosen, that car is traveling below 25 miles per hour. So I need to use my empirical rule to figure that out. So if you'll recall, anywhere from 25 to 45 is 2 standard deviations above and below the mean. And using the empirical rule, we know that that area in between the two flags is 95%. So if I take 100% and subtract that 95%, it's going to leave me with this area and this area. So in other words, if I do 100 minus 95, I'm really subtracting away this piece right in here. So it's going to leave me with 5%, right? But that represents either side of the flag. We only care about this side. So I need to divide by 2 because remember, one of the properties of the normal distribution is that it's symmetric. It's the same on both sides. So these flags are the same distance from the center. So I'm just going to do 100% minus 95%, which gives me 5%. And then I'm going to have to make sure I take the 5 and divide by 2, which is 2.5%. So the probability that a randomly selected car is traveling below 25 miles per hour is actually just 2.5%. Now I want to know, what is the probability that a randomly selected car on this road is traveling between 35 and 40 miles per hour? Okay, so I'm going to take this this picture here, and I'm just going to copy paste. Okay, I'm going to shrink it down, and I'm going to, let's see if this will work. Let me put that back a second. Let's see. Okay, instead of redrawing, I can just go like this, and then maybe I can erase that stuff. Okay, so I'll do the best I can getting rid of this stuff. All right, I don't want to mess with it too much, but hopefully you can all see now. So now I'm looking for 35 and 40 and in between, right? So let me use a different color here. So 35 is here and 40 is here. And there's a couple ways you could do this, okay? So one way that stands out is, if you'll remember, between here and the furthest orange flag, so here, that's 68% of the data. It falls within 1 standard deviation. But I'm only looking for the probability that someone traveling on that road is going between 35 and 40 miles per hour. So using one of the characteristics of the normal model, I know that it's symmetric. So all I would have to do is divide this 68 by 2, because this area is the same as that area. And 68 divided by 2 is 34. So approximately 34% of cars traveling on that road will be traveling between 35 and 40 miles per hour. Okay, we know that the middle 95% of cars are going to be 2 standard deviations above and below the mean. So we know they're going to be between 25 and 45 miles per hour. And almost all of the cars on this road would be traveling between 20 and 50 miles per hour. Anything beyond those two values is extremely rare. In this book, we say anything above 2 standard deviations is rare. So the probability that someone is driving more than 45 miles per hour on that road would be rare. And the probability that someone is traveling less than 25 miles per hour would be rare. So if you think about it, anybody going above 50 or below 20 would be extremely rare. So mostly everybody, 99.7%, are traveling between 20 miles per hour and 50 miles per hour. The reason we can't say 100% is because, remember, the whole curve represents 100%. So that's the end of this lesson. We're going to see more of the normal distribution throughout the entire book. So it's really important, this section, that you understand z-scores and also the normal distribution. So please go back over the notes and go over the summary here. These are highlighting the important things that you need to know. And then there's the homework at the end. This is the bare minimum of practice that you should do to feel comfortable with this section. If you need more practice, I can provide more problems for you to try. But doing these problems is, again, the bare minimum. If you've never seen this before and you need practice doing it, because a lot of what we're going to do going forward will relate to z-scores and the normal distribution, and your understanding of it is critical to understanding the rest of the course. So please reach out to me if you have any questions, and I hope you all enjoy the rest of your day.